This is Management Information System, Chapter 12, Systems Planning and Development. When a company begins trying to plan for information systems, they need to make sure that these strategies that they're using for their information technology are also aligning with the overall strategies of the organization. Companies make major investments in information systems, not only in dollar amounts being spent, but in the time and effort put in by their employees and consultants that they hire. So the investment in time and money is tremendous. We need to make sure that these IT strategies are aligning with the overall strategies in order to help ensure success of the implementations that we attempt to accomplish. Some key steps in IT planning to make sure we create both a corporate and an IT mission. We need to know what the goals of the company are and how the goals of our information technology are going to move us toward those overall corporate goals. There's a vision for IT. We can consider the vision as to where we think the IT should be moving, what direction, maybe the goals of what the ideal technology would look like in our organization. Then we need to create strategic and tactical plans to try to implement these technologies and move us in the direction we plan to go. After that, we need to create plans for operations as well as budgets to ensure that the resources are available for us to capture these systems and move toward our mission statements and our goals. The CIO, or the Chief Information Officer, usually develops the strategic plans as far as what technology will be used. And the goals in these plans should be broken down into objectives, such as timetables for when we're going to acquire the information system components, as well as when training and how much training would be taken down. The objectives are then broken down into operational details. In today's market, a growing amount of IT funds or information technology funds are being spent on software. You want to remember that the software is where the end user actually gets the benefit from the systems. We don't really get the benefits, for the most part, from the hardware. Perhaps one piece of hardware would be faster than another, but the real benefits come in being able to analyze the information and get the answers that we need to conduct business. And so that comes from the software. Most companies today are purchasing a software and then adapting it to the needs of the business, as opposed to trying to create their own product from scratch. So a mission statement is a paragraph that communicates the most important overarching goals of the organization for the next few years. The IT mission statement needs to be compatible with that overall organizational mission statement. It defines the role of information technology in the corporation, and it is usually a paragraph or paragraphs describing that role. Sometimes the IT mission and the IT vision are both combined into one statement, And the vision includes what the ideal combination of hardware, software, and networking that would be combined together to support our mission. It's also important to remember that because IT advances so quickly, it is often that the IT mission statement is prepared for no more than 5 years. So usually somewhere in the area of usually 3 to 5 years, because beyond that, the technology is changing so quickly that we don't know what exactly will be available. This gives us a visual of all the different things that we've just discussed that show the breakdown. The goals that are laid out in the strategic plan are then broken down into objectives in the tactical plans, and then we come up with a specific plan for operations to reach those goals. When we work with information systems, we need to be able to keep track of the changes that we are making inside the organization as well as in the system. Change management is a structured, disciplined approach that facilitates the adoption of new systems and the modifications to existing ones. So companies plan ahead. They try to think about what they're going to need in the future. They look at what enhancements they want, and they plan those enhancements out to spread the cost of that investment, hopefully over a longer period of time. When we're standardizing our systems, we do get some benefits. I have a client right now that were purchased by a larger company. That larger company has one information system throughout most of their organizations, but because this company was already separate and in place, it had its own information system, its own ERP system and manufacturing system. So because it's different, it adds a different layer of cost. They cannot buy the same hardware and software for this facility as all of their other ones. And they also have to have training and support that would be supportive of the needs of this client, and it's different. Those people have to know different sets of hardware, software, and networking devices. And so it adds another layer of cost to the organization. The goal for them is to eventually standardize their systems so that this new facility would be on the same system as everyone else. That standardization gives us the advantage of cost savings to get better bargaining when we're buying our hardware and software. It also gives us more efficient training and efficient support. It also can help when they are trying to hire these people to provide the support and the training, because they can focus on the devices and the software that they are using and hire people that already have that expertise. Another thing to remember when you're working with organizations is that IT professionals are not the only people that play a role during these system development projects. Any end user could be called on to participate in the process, not just to provide input, but to be a member of the development team. IT professionals used to work kind of on their own and assume that they could figure out what was best for the company, and then once they had it all figured out, they gave it to the end users and said, here's what you're going to use and how you're going to use it. Now, IT professionals have learned that they need to take advice from those end users. They know what they need to do and what they need to have to complete their jobs. And so incorporating them in the process is likely to increase the success rate of those projects. My son-in-law, Mitchell, he was asked to be on a team for locating and implementing a new system for customer resource management within the company he was working at when he first got out of college. Now, he did not have technical skills in information technology, and nor did he have any experience working on other platforms other than the one they were trying to replace. However, what he did have was the knowledge of what problems they were having with that existing product and what they needed to fix. So they needed him to be on the team to help them ensure that any new product would not lead to more problems, but would fix the problems that they were having. So as we move from the planning to development, management has to decide how it's going to obtain the new systems. There is basically two approaches, and these are pretty much going to be the same whether or not you purchase the product or you try to create it yourself in-house. The two approaches are the traditional approach, which is the systems development life cycle, sometimes referred to as a waterfall approach. And we'll talk in more detail about both of these approaches. The system development life cycle is more structured, and it follows some predefined steps and tasks that try to ensure that we have a successful implementation. Newer methods called Agile methods are another approach that developed out of creating prototypes. These are designed to help cut the cost and the time required to implement a system. And there are some cases where they make a lot of sense to use. So as we go through the rest of the chapter, we will be talking about the two different approaches and why you would choose to use one over the other and when it's a smart decision to use one over the other. Prototyping is a faster development of applications. What we do is we make some changes and then the user tries them out and then they go back and make more changes, and it's a continual process of prototyping. These two approaches are not necessarily mutually exclusive. You may end up using bits and pieces of both of these depending on the project you're on. The systems development life cycle is a traditional approach. Large information systems that address structured problems like an accounting system or a payroll system are usually conceived, planned, and developed and maintained within this framework called the system development life cycle. This life cycle begins after the planning phase and then moves into these four phases: analysis, design, implementation, and support. Typically with the system development lifecycle, we do not deliver pieces of the system, but we wait until the entire system is complete to begin using it. And this also assumes that once we finish the support part of the process, then a new need is going to be discovered, and we are going to begin all over again. So we're going to cycle back from support into planning and analysis and start the process all over again. So if you think about an accounting system for a corporation, they design the accounting system that they think they need, they analyze it, figure out what they want, design it, and then we implement it. Then we need to provide support, answer questions, train users, fix problems, and then at some point we decide it's not doing what we want anymore. So we cycle back and start all over again with the planning and then the analysis. This is another visual showing you that cycle. So we start with planning, then we move into analysis, design the system, implement it, support it. Sometimes during the support process, we find different changes that we need to make that are minor changes. So we may cycle back to design and design some additional interactions or modifications, implement those, and we keep cycling here until we decide that it's a major changes that need to happen. The system is obsolete. We can't use it anymore, and we cycle back to the beginning and start all over. Because this forms a cycle instead of stopping after support, they refer to it as the system's development life cycle. The book tells us that it's been estimated that over 80% of our software projects fail due to being over budget, delayed, missing functions that were critical, or a combination of all of these things. So this analysis phase is designed to help us avoid many of those problems. Two important factors that can lead to a successful implementation are to make sure that we are choosing the development process that's appropriate for the project. So if it's a large system that's highly integrated, things like that, we need to use a broader approach to developing changes to it, which is what the system's development lifecycle does. We also need to make sure that we have established the requirements of that system. We know exactly what it needs to do. And that's part of this system analysis process. So if we do an efficient job at the analysis phase, we can help eliminate many of the software failures that have been noted in businesses. So in systems analysis, we have these 5 phases that we have to look at. It's almost like it's 2 phases, but one of them is built up into 3 parts. So we start out by investigating what are the options that we think we could use, what opportunities exist and we want to seize that would cause us to need a new system. Then once we figure out what's available for us to use, we're going to then move into feasibility studies. So all 3 of these middle processes are feasibility studies. We look at technological aspects of it, economic as well as operational. And then the last thing we develop is a list of requirements or things that the system must be able to do in order to be useful for our company. So this gives you a visual. We start out investigating what the options are. Then we look at what we want. Is it feasible in all 3 of the feasibility areas? And then finally that leads us down to the system requirements, what we want the system to do. So during the investigation, which is the first step in systems analysis, we determine whether there is a real need for a system and whether the system that we think we need is feasible. So a small company or a small group, a small team is going to look at this preliminary investigation, trying to figure out, do we really need a new system, or is a new system not going to fix the problems that we're experiencing? Once we get past investigation, we move into feasibility studies. We need to look at the feasibility of this new system excuse me, based on all three feasibility factors: technical, economic, and operational. So with technical feasibility, we're looking at, do the components exist or can they be developed? Is there adequate hardware available on the market to do the things that we need it to do in order to make this system work for us? Economic feasibility is looking at the cost-benefit analysis of this project. The development of a new information system is only economically justified if the benefits outweigh the costs. And the development of new information systems must be economically justified the same way any other investment would be. We often try to calculate the return on the investment, which is the difference between the benefits, the dollar amounts of the benefits and the stream of the dollar amounts of the cost over the life of the system. So we use calculations to estimate the benefits and the costs, and then we try to determine the return on investment. If the return on the investment is positive, then the system is economically feasible or cost justified. Now, sometimes laws dictate that the implementation of a new information system is required. When that is the case, for example, when companies had to implement new software because of changes in the law from Sarbanes-Oxley, then the question is not whether or not the system is economically justified, as much as it is which is the least cost system that will achieve the adherence to the laws. If the law says we have to change, then we do have to make a change. So then we try to find the best solution for the least cost. With operational feasibility, we have to look at, will this new system be used? I can remember one time I was at a client. Their accounting system was very out of date. And they wanted to get a new one because it was not functioning well. It was causing disruptions. It would go down and stop working. They were just having a lot of issues. It wouldn't do all the things they needed it to do. But when it came down to us showing them a new system that would meet their needs, it was definitely economically feasible. But they said to us, our bookkeeper that will use this system is set to retire next year. We do not feel that it makes sense to bring in a brand new system. We don't think she will learn it well or use it well, and she's going to be retiring soon. So rather than implement the system at that point, when likely it would not have been implemented well, they would have had to pay for additional training when that person left because the person didn't know the system well enough that was retiring. There was a high risk of failure because the new employee would, or the existing employee would not be interested in change. And so they decided to hold off till that person retired and implement the system in a few months after that individual had left the organization. So sometimes we have to look at, will this work in our environment? Will the corporate employees be willing to work with it? And if not, what can we change to make it so that it is operational feasibility? So we do have to look at the operational cost of a system during its lifetime. Things like software licensing. Most of the systems I work with, you have to pay annual recurring fees to keep the software updated every year. You have to pay maintenance fees. You may have training issues that you have to deal with. There could be power issues or maybe issues with connecting to the internet. All of these things have to be addressed as operational costs. The total cost of ownership must be considered because we have to look at not only the cost of buying it and implementing it, but the cost of keeping it up to date and running. The last part of our systems analysis phase is developing the list of system requirements. These are the functions that the system is expected to fulfill and the features through which it will perform its tasks. So it's everything it needs to be able to do and all of the questions that we need it to be able to answer. If I know that I'm going to be emailing purchase orders out, I need to make sure it will handle those purchase orders and it will print them in the format I want, automatically email them the way I want, and that my vendors are going to be able to then respond to that information. If we do not have a complete set of system requirements, what typically will happen is we will pick a system that looks good, sounds like it will work, but when we implement it, it will be missing some of the key things that we need. Then we spend more resources either trying to find a way to add those things to the system, or we end up having to buy a different system and start over again. So this systems requirement is a very key part of a system implementation and its success. Once we have that list of requirements, now we can begin moving into the system design phase. In this phase, the purpose is to devise the means that all of those business requirements can be met. So we're going to create a massive report that we can then use to compare different systems and make sure that those systems are going to be meeting all of the needs that we have identified in that document. So we would go out, we would maybe, if we were purchasing a system, we would probably compare multiple different systems, compare how each of those systems would achieve what we want it to do. It's important to remember here that we don't want to just talk to the vendors that are providing the software and have them tell us that this system will do the things we want. It's also important to have them show us how does it do it, because the last thing I want is to have to jump through 15 hoops to make something happen that is critical in my organization if there's another system that I could press one button and it would instantly complete that task. We're also going to be trying to document what we need in the system in this part of our design phase. So you can see here we look at these different symbols. We will be describing what the system needs to do, then move into a construction phase where we will be setting it up, and finally we will move into the testing phase. These steps are all within system design. So we have data flow diagrams that we can use to help us draw out the flow or the movement of data in the organization. A carefully drawn data flow diagram can provide useful representations of the system, whether it's existing or whether we're just trying to plan for it and we're documenting what we hope it will do. With this data flow diagram, the simplicity of it is its advantage. It only has 4 symbols that you have to work with. And so that helps make it easy to understand and easy to create. It's important to remember when we're diagramming these things that a picture paints 1,000 words. It's kind of similar to creating a chart. The numbers present a story. The story becomes more visible and more understandable to everyone if we put it in the form of a picture. The same happens with these documents. These data flow diagrams can help us point out weaknesses in our system, and they can also help us point out areas where we maybe fully don't understand the system yet. The 4 symbols that we work with are external entities, and these are individuals or groups that are either inside or outside the company but external to the system itself. So it could be employees, customers, departments, vendors. Then circles are processes. These are events that take place and change our data in some way, shape, or form. A data store is a place where we are storing or the data is resting. It could be a filing cabinet for paper data, or it could be a database being stored on a network if it's digital data. And then finally we have the directional flows or the arrows that indicate the movement of the data. So we can use data flow diagrams to describe systems even if they are not computer-based. So if we're trying to take a manual process and turn that into a computerized system, we could draw out the data flow diagram that describes the way the system currently is, and then look for places that we could use computers to automate these processes. We can pinpoint weaknesses by allowing us to see maybe where data is being created and stored in multiple places, but it's the same data. We might also see where processes could be improved and strengthened to create a better system overall. These documents become a blueprint for what the system needs to do. Here is another example of data flow diagram symbols. And this is an example of the data flow diagram. We have the sales clerk providing their ID, along with the sales database that pulls in the annual sales and perhaps the percentages that that individual gets for a bonus. A bonus calculation is a process that generates the bonus amount, which is going to be stored in the bonus file. So it's a very simple, easy design that we can follow. Another way that we can visualize systems are through the unified modeling language. or UML. This is a graphical standard for visualizing, specifying, and documenting software. It helps developers to communicate and logically validate that desired features are going to be in the system. It is independent of any programming languages, which make it very easy to use. And it uses some very simple symbols. Now, several diagramming sets were originally developed in the 70s, but by the late 90s, the UML became the de facto standard and is what is used by most organizations today. There are 6 types of UML software. We have use case. A use case is an activity that the system executes in response to a user. The user is referred to as an actor. The use case diagram the communication between the relationship between the actor and the case. There can be class diagrams, which describe the class structure and content, and they use names, attributes, and methods. We have interaction diagrams, which describe interactions between objects and the sequence of the activities. State charts communicate the states through which an object passes, as well as its responses to signals that they receive or stimuli. Activity diagrams represent highly active states that are triggered by the completion of actions of other states. So they focus mostly on internal processing. And then finally we have physical diagrams, which are high-level descriptions of software modules. And they describe the software and the execution that the software components go through. This is an example of a use case diagram. So our order clerk enters a new customer. Perhaps they create a new order. It comes down here where they create the order in the sequence diagram. They verify that the customer exists. They are looking in the order and the shipment and the customer information. When the item is ready to be shipped, it then goes into the ready to be shipped to be sent to the customer. Once we have done the documenting phase of our system design, we move into the building and testing, or the construction and testing components. So system construction is typically programming. Professional programmers are going to translate the input, output, and processes described in the data flow diagrams, as well as the unified modeling language diagrams. And they're going to turn those into computer programs. Sometimes these programs already exist and we're just making some modifications or changes to them. The effort, depending on how many changes you have to make and what already exists, could take months or even years. When a specific module is completed, that module would then be tested. So testing is performed as simulations or walkthroughs that would allow us to see if that particular piece of the system works by itself. We don't just stop there, though. When all of the applications have been completed and successfully tested by themselves, Then we have to try to integrate the entire system together and do system-wide testing that is going to test all of the components working together. If we skip this system integration component test, or the integrated testing, we could end up having pieces that work, but then send another piece of the system incorrect information, causing errors somewhere else. We need to be able to check the system requirements against what's actually working in the system to make sure that those originally defined requirements are actually met. We need to inspect the quality of the output and the processing times that are being seen in the system to ensure that it is going to work for our business needs. We also, when we're testing, actually need to try to make the system fail. Think back to when we created our validation rules in Excel. I told you that the smart thing to do after you created those validation rules was to then test them to see if you would get the error messages when you expected to. So we have to try to outsmart the system and ensure that when we do something we should not do, it will cause a violation or an error message to appear so that those things don't happen when we are using the system. Now, probably because this is one of the last steps before we start implementing, sometime this segment, this testing period, gets shortened. Maybe they're really anxious to get the new system up and running, and maybe they're over budget and they want to try to compress this process. And so they end up doing a poor job of testing because they cut it short and decide that there's been enough. The rush in testing can lead to many failures and actually ends up making the system implementation take longer and sometimes completely having to start over and go back. So testing is an area that should not be skipped, even if you're on a budget crunch. After this, we begin implementation. So implementation is changing to the new system. So it's also called delivery, and it consists of 2 steps: conversion and training. So conversion is how are we going to stop using the old system and start using the new one. And there are multiple ways or approaches we can take to that conversion. Training is actually making sure that our end users know how to use the product. Now, ideally, some of this training should happen before the conversion takes place. Otherwise, people will not know how to do their jobs. So ideally, some of the training or much of the training would happen before the conversion. But typically, there's also some training that needs to follow the conversion so that the users can get their questions answered. So let's take a look at different ways of conversion. There are 4 main ways that we can look at for conversion. The first method is called a parallel conversion. So this one we're using the old system and the new system simultaneously. So we use them both at the same time. This leaves very little room for error. What we're going to do is we're going to run them both, compare the answers, and after a period of time, when they are both consistently giving us the same answers, we stop using the old one. So this reduces a lot of risk. However, it can be very costly and very frustrating to your employees because now they have to do everything twice. Some key systems I have run parallel with. For example, I had a client who we did 2 payrolls and a month end in their payroll processing simultaneously on the old system and the new system to ensure that we got very similar answers. The taxes were within a penny. The deductions matched. All of the things on the paychecks matched. Because we wanted to ensure that this new system was set up perfectly, because this affected people's income and their take-home pay. We only did this for 2 periods or 1 month. 2 payrolls. They did 2 each month. We didn't do it for a year or 6 months because it's very costly and very time consuming. But to do it twice to make sure we got the same answer in 2 different payrolls gave us a comfort level that it was working correctly. I had another client who wanted to implement an inventory process. They wanted to keep their both systems running for an entire year to ensure that by year end they were still getting the same answers. Thankfully, we were able to convince them that that was way too long and that was way too much work for their employees, and we developed a different approach. For a phased conversion, we're going to break that new information system into segments or modules, and we're going to implement one at a time. So this reduces your risk, but it also delays some of the benefits because you don't have the fully integrated system all working at once. By breaking our larger system into functional modules and phasing them into operation one at a time, we can help with the training aspects of it because employees can focus on learning one task at a time. And then when they've got that comfortable and mastered and we know it's working properly, then we can move on to the next step. But it does sometimes mean that there has to be some double input of things. For example, if I'm using the payroll in one company or in one system, and then I have not begun using the general ledger or the other parts of the accounting software in that new system yet, I have to enter general ledger entries from the payroll system into the old one so that we have that yearly or monthly financial statements correct. So it can mean some extra work and risk for error in that way as well. Now the next way is called a cutover or a direct conversion. It is sometimes referred to as a flash cut conversion. What that means is tomorrow I stop using the old and I start using the new. This is extremely risky, especially if you cut short testing or any other of the developmental pieces that came before this, developing your list of requirements. If you didn't do a thorough job of that, then if something does not work, you have already stopped using that old system. So to go back to the old system would require you to put the old system back in place and re-enter everything that had happened while you were using that new one. So that can be very costly and expensive if it does not work properly. So the immediate cutover does lead to some risk. And even though it's inexpensive because you just stop using one and start using the other, sometimes the risk involved with mission critical systems makes us not want to do that. And the last type of conversion is called a pilot conversion. Now the software textbook uses the example of a software company. If they're producing a product for a lot of different places, they might pick some beta sites, which are sites that are going to test that system. And they would implement in these beta sites for a pilot site first, and then move on and implement other places after they've resolved any problems. I would tell you that this is used more than just with software development companies. For example, my husband works with a company that they do manufacturing in multiple locations. So they picked one site to begin that conversion. They implemented the new system there, made all the adjustments to make it work for that company, for that location, and then took that knowledge and that information and implemented the system in a much quicker, more efficient way at future sites because they already knew the types of changes and problems that they needed to address in the first one. This gives you a visual of how each of these cutover or conversion plans work. Now, the role of the IT professionals does not end with the delivery of the new system. They have to support the system in an ongoing fashion even after the implementation has taken place. They have to do a couple of different things. They are the main responsibilities. First of all, they have to help users. There are always going to be problems or questions that come up by the people using your system, and somebody needs to help them and answer those. There's also maintenance that needs to be done. Post-implementation corrections, debugging, corrections of bugs or problems, as well as updating, making changes and fixes, and adding new features that perhaps were postponed during the initial implementation process. Some companies estimate that up to 80% of the entire information system budget is made up of this support function. The support is the longest phase of the system development life cycle because you don't want to have to immediately change to a new system. You hopefully have picked one and designed it well enough that it will work for a while within the company before you have to start all over again. So obviously, this section of the life cycle should be longer than the others. So although maintenance, which is a part of the support phase of the system life cycle, is viewed as lacking in glamour by most professionals in the information systems industry, it should not be taken lightly or left to the less experienced professionals, because if the changes are not made and documented well and tested well, they can cause just as many failures as the initial implementation itself. When the full approach of the system's development lifecycle method is too much for an organization or for the system at hand, sometimes they look for these agile methods. The system's development life cycle is considered to be longer, more expensive, and less flexible than these agile methods. So they treat software development as a series of contracts with users, with the goal being the fast development of software to satisfy the requirements that have been identified, and then improving the software shortly after the user requests modifications. Agile methods make use of interactive programming, using the users often get involved and keep the programmers open to modifications while the development is still underway. So basically they're going to come in and they're going to say, here's an example of what we can give you, and the user uses it for a little bit and comes back and says, well, you know, I like this, but I would change this, and I want you to change this, and they make changes, and then they can bring those back and say, okay, here's what we have now, what do you think? And the user uses it for a little while, and then it goes back and forth in this iterative process. These are some examples of the popular Agile methods that we see being used currently. So we had tried to identify some preliminary system requirements, but one of the things that is often said about using these Agile methods is they're effective when the user doesn't know all of the system requirements. So they start developing them as they go. But we construct a working model, the user tries it. If it's unsatisfactory or they think they want things changed, then they develop more requirements, they come back, they try it again, they come back, make more changes, try it again, and then finally when they said, yeah, this is what we're looking for, it gets delivered. So the major advantages of this Agile method is that it's faster. It's faster to develop the software, and that is the huge advantage. The risks are because the analysis phase is very minimal and sometimes not done at all, then there is an increased risk of things being incompatible with other systems that perhaps it needed to integrate with. There's also an increased risk of it not meeting all of the needs of all of the users. And developers devote most of their time to construction and very little time to documenting the system, which can mean that later modifications can be challenging because they don't understand what the system is doing completely. So Agile programmers like to express these priorities, that individuals and interactions are more important than processes. Working software is more important than comprehensive documentation. Customer collaboration is more important than negotiating the contract. And responding to change is more important than following a plan. So these Agile methods typically have less planning and more quickly get into that development and changing phase. The modules are tested immediately, and sometimes the system-wide testing or integration testing falls by the wayside, and then we have issues with trying to have these systems work together. So when do we want to use Agile methods? Agile methods are an efficient approach to the development of a system when it is small, when it deals with fairly unstructured problems, and when the users cannot clearly specify all of the requirements at the beginning of the project. So the requirement list has to kind of grow as they start working with things and seeing what their options are. These are times when it's effective to utilize these Agile methods. When should we not utilize these Agile methods? If a system is very large, there's a significant investment involved and a huge risk of financial loss, and so more planning and the broader scope of the system's development lifecycle would be recommended. If the system is extremely complex, then we should also be using the system development lifecycle in order to allow for extra care in documenting both the requirements and the integration concerns that we have within the system, as well as documenting the system carefully so that we can change it going forward if we need to. So if documentation is key, then we need to be working with the systems development lifecycle. If this system is designed to interface with other systems, then we should be using the systems development lifecycle so that we ensure system-wide testing of all integrations and not just rolling out one module at a time. So it would not be recommended for large accounting or ERP systems because they have many integrations that we have to account for. This shows you some examples of when to use Agile methods as well as when not to. Outsourcing is a growing industry in the information technology world. It is steadily used by many organizations and can help them maximize their value as well as reduce their costs. When we outsource, we are forming a formal business relationship to transfer internal business processes and functions to a third party. So for example, the companies that my husband's company works with, they could hire their own technology experts in the software and in the hardware and other tools that they are using. Or they could seek the expertise of individuals that work for another company and outsource that to create efficiencies. Not all outsourcing initiatives are successful, but many are. We also have project portfolio management tools. These are sets of processes and methods used by project managers to determine which projects will meet the organization's operational and financial goals in relation to their strategic objectives as well as the needs of the customers. So many of these tools are available to us and they will help us accommodate making sure that we are planning the project, that we are not going over budget, that we are keeping track of which tasks are outstanding and who needs to work on them. And it is a process of maintaining the path while we're trying to keep track of the economic balance between the factors of cost and time of the implementation as well as quality. So we track testing in these tools. We can track other products to make sure that everything that needs to happen in this process is happening and we don't forget any of the testing or any of the other tasks that need to take place. Systems integration is a term that refers to when we have multiple systems that need to be connected or interfaced so that they will work together. This is often more challenging than the system development itself. Systems integration has to look at the information needs of the entire organization, or at least major divisions within it. And the analyst has to consider existing information systems and then produce a plan to allow new data flows to connect into those systems. Systems integration has become increasingly important because many companies are integrating other information systems into their websites, and also because legacy systems are being integrated into new applications. Legacy systems are older systems that the organization decides to continue to use either because the investment in a new system is not justified or because the old system has advantages that cannot be obtained from the newer one. Systems integrators need to be well trained in both hardware and software issues in order to be able to connect different types of hardware and software. Sometimes hardware and software can be incompatible to use together, and overcoming these incompatibilities is one of the biggest issues that they have to deal with in working with these system integrations. The concept of extracting business intelligence information from large data warehouses often involves the integration of several information systems and is one example where this integration is taking place. So this gives us some examples of initiatives where we are integrating. Companies are linking websites and smartphones as well as tablet applications and databases to work together. And so we need to be able to integrate all of these things to share information because we don't want to store the information in multiple places. Now, certification is meant to try to help guarantee that the experts that we hire have passed tests to ensure that they actually have the skills that we are hiring them to do. Certifying people which have knowledge and skill in a particular discipline that is significantly greater than that of a normal layperson would have. So many people feel that proponents of certification feel that this certification could reduce the number and the severity of malfunctioning information systems. They believe that certifying would allow people to be better able to hire people with required skills, and they would be better able to evaluate someone's expertise even if they do not have that expertise themselves. So if I'm trying to hire someone with a certain networking skill that I need in my organization, it's very hard for me to evaluate whether they know what they're talking about because I don't understand what they're talking about. And so it becomes very challenging to hire those people. Many of the proponents of certification believe that this could be a benefit to organizations when they're hiring. If there was certification that was required, then you could show that this person had passed a test in that area. There are certification programs that people can take tests to prove that they are competent in different areas. We talked in class about Microsoft Office Specialist certification that you can get in the different Microsoft products, and that's one form of certification. It is not, however, required for technology people to have these certifications. Some of the cons that people argue is that some people believe it would be difficult or impossible to measure competence in software development because there are so many different tools and applications that we could use for that process. Other people argue that it would limit the number of people who could get into the market. It would close the group so that it would become very limited number of people. And then the second thing is it also, people fear that because IT progresses so fast, ensuring that they know what their skills are would mean you'd be constantly taking tests and retaking tests. And a test that you took to get certified today, 2 years from now, would be irrelevant. And so they also look at that as a con against it. If you have certain skills that you can represent by passing certain certification tests, that certainly would make you more marketable in the industry. So for example, much of what we went over in the Excel segment of the class is what would be on the Microsoft Office Specialist Excel exam. So if you felt you wanted to try to take that exam and become certified, then that would be something you could present to show that you had mastered the skills in Excel, and it would make you more marketable to people that were looking for that skill. That ends Module 12.